next up, we have Brian Kaufman, who's going to talk about multi-cloud, hybrid cloud, how to be successful with app modernization. So we covered the build part with APIs. We did DevOps with Mahashad. Now we are down to the deploy. Now we are looking more at the deploy, compute, runtime part of our app mod sessions. So specifically, Brian here will get into demystifying some of the buzzword bingo around hybrid cloud, multi-cloud, what that means with GCP, how to make all that real. And so, Brian, take it away. If you're ever confused about multi-cloud or hybrid cloud and how GCP can help, this is the session for you. Thanks.
Great, thanks, Rhett. And I have this right here if anyone has some questions. Let's make it as interactive as we can. So my name is Brian Kaufman. I'm the product manager for Anthos Multi-Cloud. So I'm one of the few people at Google Cloud that talks about running Google technology outside of Google Cloud. My products are very container-centric, specifically Kubernetes. How many of you all in the audience are familiar with Kubernetes, either in a development environment or production? Just raise your hand so I know everyone kind of understands where I'm coming from, get a baseline. What we want to do here is simplify the end user experience. This I just stole from Mike in the opening for today. This is kind of the talk track for a lot of the technology that I'm going to walk through. To make this kind of fun, I want to set a challenge for this session. I want to picture myself as working for a large enterprise, and I want to create a GitOps-driven workflow that allows for full Kubernetes lifecycle management on any cloud, across any environment, and I want to build in standardization, security, governance into every layer. And I also want to figure out a way to make it self-service. I got a little jealous of the Apogee presentation. I want to make it so my infrastructure team can utilize this same type of internal wiki to figure out how they can spin up resources and not have to really get bogged down with the platforms team to configure all the nuts and bolts for a very specific request I might have. So I want to kind of take a break from these slides and take an example template here. And I have a Git repo. And I want to make an Amazon EKS cluster. EKS, Amazon Kubernetes. I have a custom template here that has a few different parameters in it. I have the name of my cluster. It's going to be A-team. I have the size of the Amazon node I want to use. I'm just saying medium. Kubernetes version. And then I have just some other information here, admin users, myself. I want to be able to log into this cluster when it comes online. So I'm going to save this. This is what I want to build. This is the self-service that I want to create for my end users. I'm going to commit this to Git. And now let's go back to our presentation here. For a true multi-cloud strategy, we need something that spans the infrastructure layer and the configuration layer of specific technologies such as Kubernetes, right? We don't want to manage multiple areas of the stack in a different way. We want a unified approach to everything. And for that, I'm going to use GitOps, so storing things in Git as a single source of truth. So there's 3 parts to my talk here. The first is we're going to talk about why Anthos for Kubernetes environments. And if you're not familiar with Anthos, I'm going to tell you what it is in the next slide. After we discuss Anthos for Kubernetes, we're going to talk about Crossplane. And if you're not familiar with Crossplane, I'm going to tell you exactly what that technology is after the Anthos part. And then the third part will work with a live demo of the system and show you just how easy it is to accomplish my original problem statement of a self-service pipeline for infrastructure and Kubernetes management across clouds, across environments. So let's get started here. What is Anthos? So Anthos is a suite of products that are built around Kubernetes that you can deploy across environments, whether they're on Google Cloud, in your data centers, on bare metal, or in other clouds. The first layer of the Anthos stack is Kubernetes. You can use Google Kubernetes or you could bring your own. On top of that, we offer a service mesh. You have a lot of applications talking in containers. How do you do service discovery? How do you manage encryption, telemetry, intra-cluster communication, who's talking to who? Those are some of the things the service mesh solves for. On top of that, we provide a runtime for serverless applications. That product is called Cloud Run. And then we have various tools to help you manage the configuration of the clusters and the policy. For purposes of my product, we're running in clouds. It's very easy to open public IP addresses, download stuff off the internet, and run it. Name your vulnerability. It's very easy for a developer to go in there and change some code. So policy management is very important. We want to lock down the clusters, make sure there's guardrails in place so our developers get secure landing zones. They can launch whatever they want, and the risk is centrally managed. Finally, centralized ops management. So your telemetry, your logging, everything gets sucked up to Google Cloud. Managed Prometheus is one of the data sinks we can support. So very easy to unify your operations management, whether you're in Amazon, Azure, on-prem, all the above, Google Cloud. So these 5 components, this is the Anthos stack. It's definitely not all or nothing. There's customers that use bits and pieces of this. There's many customers that use all of it. But this is what Google has developed to offer a full enterprise Kubernetes platform. And this is very similar to how Google manages Kubernetes internally. We have policy management, centralized ops, serverless, all those sorts of things. Now, the final piece of Anthos is what we call the Connect Gateway. So you're launching Kubernetes clusters in multiple environments. You don't want your developers to have to manage a VPN to log into all these things. It could get very nasty from a networking perspective. The Connect Gateway allows you to deploy agents onto each cluster, to establish an outbound gRPC tunnel back to Google, where developers or your administrators can centrally log into each cluster regardless of where it is. So very easy to create clusters, to secure them, to log into them, to manage the logging, monitoring, and service mesh, et cetera. Very complicated product. I tried to boil it down for you. Hopefully everyone understands it here. Yep.
Can you provision this Anthos resource from the GCP directly, or is it like a separate installation? Or what?
Great question. So this is part of my demo. So if I can hold that, we're going to provision Anthos live. Any other questions before I move on? The reasons people are drawn to Anthos, it's standardization, security, and governance. These are the principles of why people adopt the Anthos platform and don't try to piecemeal things together from the open source community. Service mesh, another big selling point of Anthos. A lot of customers have run full speed into containers, into clusters. Doesn't take long before you realize that services in cluster A need to talk to services in cluster B. You need some way to have service discovery. Service mesh helps you. These are the fundamental reasons people choose Anthos. Now, if we're talking about standardization, security, and governance, that falls under a topic of sameness. When you build clusters, you want everything to be as similar as possible, and that's something that is done at Google. All the Kubernetes clusters internally to Google are exactly the same. People have different resource quotas in different regions that allow them to spin up their applications. But the namespaces that people are allowed to use are unique across every cluster. So these two, the Anthos tooling, rather, helps you establish the sameness concept across your Kubernetes deployments. Now, I wanted to zoom in on one specific feature of Anthos, which is the configuration and policy management. There are tools in the market that help you deploy things to Kubernetes. Argo, Flux, people use Jenkins. You could pretty much use anything that can talk to a kubectl API. Anthos supplies a tool called Anthos Configuration Management. You can see it on this slide at the bottom. It's called ACM. This is geared towards platform teams to make sure that you have the necessary tools installed on the clusters before the applications get deployed. So think about your security tools. Maybe you're using CloudStrike. Maybe you're using Splunk for logging. Your RBAC policies, config maps, anything you absolutely need present on every cluster before the apps in a drift-controlled manner, meaning someone can't log in, just delete it, and it's gone forever, meaning it will come right back if someone plays around with it. That's what Anthos Configuration Management provides out of the box. So it dynamically synchronizes a Git repo with all your configurations to the cluster continuously. Policy management is part of this tool. Anthos Configuration Management includes support for Open Gatekeeper. So you can define policies like an application can't be deployed without a label, because maybe Splunk requires labels, or maybe your chargeback facilities require labels on all the workloads. So you can't have people just launching things, right? You need to know who to charge. That's one example of policy management. Another popular one is you're not allowed to open public IP addresses, right? CIS benchmark compliance. There's a million use cases for policy, but this is one of the benefits of the ACM product. And then, of course, once these are all installed, we get out of the way. You can use whatever tool you want to load your applications. So this is relevant because this is how you control Kubernetes configuration. But I didn't answer your question yet about the actual cluster. How do I spin up the cluster, right? So I'm going to get there. But this is how you would manage a Kubernetes configuration across environments, across clouds. You want everything the same, and you want to make sure your tools are always present. A quick plug on the service mesh. Very neat product if people haven't used Istio's service mesh. The Anthos service mesh, one of the 5 components of Anthos, allows for a lot easier to manage SSL certificates, telemetry collection, and a few other really nice things, including these dashboards that help you get topology views and summarize your SRE golden signals, your error rates, your latency. For those of you that have moved to Kubernetes, you realize very quickly that the legacy approach of network traces and things like that you do in a data center no longer apply in the clouds or in a cluster, right? Everything's encapsulated. It's very difficult to see who's talking to who, where the errors are coming from. All you see is the front end, right? The app's slow, or there's errors. But it could be, one of the 20 microservices in the cluster causing the error, but you're only seeing it on your website. So really nice to have. So this goes along with that sameness. Everything is designed the same. You have the service mesh everywhere, service discovery, telemetry collection. It runs with that theme here. All right, so now let's get into answering that question. We talked about managing clusters. We talked about managing the configuration of clusters, the policy, the security, the service mesh. This is a part of the Anthos proposition. What about the lifecycle of the actual infrastructure? So I'm sure most of the folks in this room have experience with, hopefully, GCP. If not GCP, another cloud. There's a lot of prerequisites to building anything in the cloud. You need networking, you need subnets, you need firewalls, you need compute, storage, you name it, right? How do you organize that in a way that helps you not only create and delete, but update and scale? For this, Crossplane has a very elegant solution. Now, before I get into Crossplane, how many of you all have experience with Terraform or Ansible? Other tools, we'll refer to them as glue, right? This is all glue, right? Gets you from point A to point B. So I want you to, understand how you're using, if you're using Terraform today in Ansible, I want you to compare what I'm showing you with what your current responsibilities are. And then we can pass this around and see who thinks this is better or worse. I think it's a very interesting take on how to solve infrastructure as code. And it involves Kubernetes, and it fits right into the Anthos proposition, which is why I'm bundling the two today. So Crossplane treats infrastructure as Kubernetes or custom resource definitions in Kubernetes. If you think about how Kubernetes works, you have a manifest that has what's called a deployment spec in it, and the deployment spec represents pods that need to be deployed out of container images. Infrastructure, or what Crossplane did, is they're taking the same sort of workflow for deploying a pod and flipping that to deploying infrastructure. So instead of writing a deployment spec for a container, I write a deployment spec for the resource I need created in GCP, in Azure, in AWS, or on-prem. And I can take advantage of all the reconciliation loops in Kubernetes. The same way that if I deployed a spec in Kubernetes and deleted a pod, the pod's going to come right back, right? This is declarative coding. It works the exact same way in Crossplane. If I log into a UI and delete something in the cloud, it will come right back because Crossplane is continuing to monitor the configuration that I've applied and making sure that it matches the cloud. This is a CNCF project, and because it's based around Kubernetes, there's a lot of very interesting abstractions that we can take advantage of. So remember, one of the, the problem that I set out to solve, I want self-service. So self-service in the cloud for some of these things we're talking about, Kubernetes, when you create a Kubernetes cluster, you need the networking, the KMS keys, the subnets, you name it, right? There's a lot of prereqs to this stuff. A developer is not going to know 90% of that, right? Not many people in the organization are going to know 90% of that. Like, who's going to know what the subnet block I need to use is for this cluster, right? Or for this node pool. You can abstract away everything but the relevant information. So previously, when I started this talk, I strategically selected a template for Amazon. Amazon takes a little longer to spin up Kubernetes than GCP. So here's when I take the GCP template and also put it into my Git repo. So the GCP template is identical to the Amazon one, but it references a different composition ref. So this is cluster GCP. Possible values I put were cluster Azure, cluster AWS. This one's GCP. I'm going to save this now. And if I go back to my presentation here, here's where I put everything together that we learned today. So I spent some time talking about the 5 components of Anthos. One of them was the configuration and policy management. That takes place in Git. I stored my GKE and EKS configs for Crossplane in a Git repo that happens to be synchronized to a Anthos cluster that has the Crossplane software loaded on it. Crossplane will take that manifest and deploy all the relevant resources in each cloud that I've defined. So let's back up a bit here. So you saw, let's see, let me make this a little bigger. So this composition ref, here's the secret sauce. It says cluster GCP. In the Crossplane world, there is a file called the composition. That's down here. And cluster GCP lists all and here's where the labeling for Kubernetes matches, right? Just metadata labels. That's how I take these abstractions and map them into other system files. Cluster GCP is a composition that represents how to build a cluster. You can see the region that I want to lock my developers in here. I didn't put that in my template because I want to control where they're allowed to deploy. Also, I've specified the node pool configuration, and if you remember in the template file, I had small, medium, or large. A developer doesn't know, perhaps, what instances they're allowed to use in any of these clouds, and each cloud has a different name for every VM type. They don't need to worry about it. I've mapped it into small, medium, or large. Other things they need to create are, not they need to create, other things I want to be in those cluster as a member of the platform team are my InfoSec tools, my RBAC policies, my security policies. So what I can do is natively incorporate the config sync object in the build out of the cluster. It's synchronizing to a Git repo that's called, in a root folder called cluster ACM. This is a different repo than the one that I was using here. This is Crossplane ACM. Crossplane ACM is synchronized to the Crossplane cluster. Cluster ACM is synchronized to the clusters that are provisioned. If I go now to the cluster ACM, I have a namespace defined that says Google, and then I have a deployment spec in here that says security tools. This just represents like a hello world, pretend this says CloudStrike or Splunk or name your favorite, security tool. This is going to get loaded on every cluster that I provision. If I want to change something in all the clusters, I'll just change it right here. It's dynamically going to get sent to all the clusters. They're checking, I believe, every 15 seconds for updates in Git. Now, if I go over to my GCP console, I just have the Crossplane cluster here now. This represents this machine right here. This cluster is, again, it's synchronized to a main Git repo where I'm storing those templates that my developers put in. If I refresh here, hopefully, we will see one or two other clusters getting created or in various stages of it. The one at the top is an EKS cluster, A-Team VRSG9. If I go into Amazon and refresh it, I see, actually I see a different name here. I think that's just my internal code. This cluster is now registered to Anthos. And if I log into it, remember that Connect Gateway was one of the features of Anthos. I can use the command sorry, one second here. I can first log into this cluster, because remember I put myself as the admin user. And now I can use the command gcloud container fleet memberships get credentials. Thank you. And then the name of the cluster, A-Team WRSG9. I'll pull down a kubeconfig file, and then I can do a, let's see, kubeconfig get nodes. So these are my EC2 nodes, and then if I look at the namespaces, we'll see a Google one, hopefully. Here it is. And then the container in here, kubectl get pods-n Google. I see that my security tools container is running. So the same thing is happening now on the GCP GKE cluster. This is the B-Team one. This takes around, I think, 7 minutes to fully provision. But what we have to understand here is on the Amazon one, why I wanted to give it a little more time when I first started. If I look at the composition of EKS, right, this is the EKS file, when I first created. There's a lot of different things you need to create to launch a Kubernetes cluster in AWS. Very different than GCP and Azure. IAM roles, gateways, subnets. But the end is the same, right? I'm still going to configure this Anthos configuration management to synchronize the Git repo and load the configuration. So what I showed you all here is a way you can use Git to manage not only the infrastructure provisioning, but also the configurations of the associated infrastructure that's created with Anthos end-to-end with Git repo. Do you all have any questions on Crossplane or on Anthos? Yep.
Yeah, this is really cool.
Actually, here.
Thank you.
I think that's on.
This is really cool. Is there any reason I would use... Thanks. Is there any reason I would use Anthos and Crossplane if I wasn't using a multi-cloud setup, but just using GCP?
Yeah. So Crossplane overlaps with other infrastructure as code tooling. So Terraform, fully supported on Google Cloud. There's no problem if you want to use Terraform. Google has another product called Kubernetes Config Connector. It's kind of similar to Crossplane, but it only works on GCP. Crossplane, I guess it's your prerogative. What you're most comfortable with is likely what you're going to pick to facilitate the setup and teardown of infrastructure.
Gotcha. So if we had a bunch of Terraform experts, maybe I would lean towards that. But if we're starting from scratch, I could choose Crossplane, and that would allow me to maybe move to multi-cloud later with more ease than with Terraform.
Exactly, and let me give you two anecdotal stories of customers we're helping right now. So we have an Anthos customer that has about 800 clusters across different regions in the world that they group by US-based, EMEA-based, and APAC. They want to upgrade all their clusters in APAC before they do the US ones. So hundreds of clusters. They currently use Terraform to do that. And that requires a pipeline for each cluster. So they need to manually go into the pipeline and change the equivalent of this Kubernetes version in every Terraform file. With Crossplane, just to give you an example of the power here, everything is based on an API as a layer of abstraction here. So this file here, it's called demo Anthos v1. It corresponds to what's called the composition file that has the same API version. If I wanted to upgrade every single cluster that was created with this API version, I can go in, and this is a developer wouldn't have access to this. This is the admin, the platform team. They would go into the composition file, and they would go into the cluster, and they would change the version right here. And this would supersede what the developer did. So with Terraform, you got to think of it as like each pipeline is a unique process that has a finite start and end. This is a continuous loop that it keeps trying to reconcile the config. And because it's all based around Kubernetes and the structure that the industry has kind of fallen in love with for how to really use declarative YAML files, it's very easy to abstract away individual pipelines and group everything through APIs like this. So one of the many benefits with the state of this, it's actually stored in etcd in the Kubernetes cluster, the same as like a secret would be stored. So at Terraform, you have those little files that get generated after each run that you need to persist the state of. This, it's all nice, fits into Kubernetes, fits into your backup routine. Google Cloud has automated backups of their clusters, so very easy to figure out how I recover from a disaster. More importantly, the states are all, it's all driven through Git. So even if the Crossplane cluster blew up, you still have the state of everything defined in Git. So it's I want to say no code, but I'm hesitant to say that because YAML files still are a bit scary at times. But it's just a very, in my opinion, lightweight way to manage infrastructure in one cloud. And if you need to add other ones, it's extremely easy to do that without modifying your front door, your pipeline. My developers would see the same files for AWS as they would for GCP, right? I could flip really quick. You could see the variable that changes is just line 10. So if I wanted to add another cloud, it's just one more parameter for my developers versus a Terraform, a new repo in Terraform and a new pipeline and all that sort of thing.
Question. Is there any integration with either Tencent or with AliCloud?
I'm not sure. I know on their website, so there's the way that Crossplane works, there's community providers, and then there's official providers, and that's a provider is the infrastructure in each cloud that they support. Their official providers, I believe, are only AWS, GCP, and Azure, but I believe the community might have support for AliCloud and some others. Yeah. Great question. We get asked all the time, how can we run workloads in China? This potentially could be a solution for that. Yep.
So when you traditionally create like a GKE cluster on Terraform, you specify your secondary subnets and whatnot. Here, when you're using composite package, how do you pass in those variables, or do you just specify a large number of ranges?
For GCP, we're just going with the default network. Okay. But for EKS, I believe we have, let's see here. So we're using just defined, so we put it in.
Okay, so if you're using like a shared VPC network, you would have to, specify one for each cluster.
Yeah, so that's a great question. So this doesn't get you out of the business of completely, speccing out everything that you would need to do normally. It's just a way that you can do it once and then abstract away that information from future uses of the pipeline. So I do this one time, and I have a way that I can easily provide self-service capabilities if I wanted to, or have my own team spin up things. But yeah, you still need to figure out all those parameters. Yeah.
And does this work with GKE Autopilot?
I believe there is support on their official provider for GKE Autopilot, yeah. just for the sake of discussion, if you go to Upbound is the commercial arm of Crossplane. We have a partnership with Google Cloud. In their marketplace, they have official providers. So these would be the equivalent of like Terraform modules. So if you can't find what you need in the community, in the open source, you can get direct support from them to build whatever you would like. And I'm sure, see if I click all providers, they do have Ali Cloud, so that's good. So I hope this is beneficial to you all. I'm really bullish on the integration with Anthos because it gives you that full story of not only how you solve for lifecycle management, but also the management of the clusters themselves in a really easy way. You don't have multiple pipelines going on to manage.
I speak to this? Oh,
You're good,
there
yeah.
you go. It works. I saw you deploying a cluster, but I didn't see you deploying an application. Maybe I missed it.
Yeah. The application's actually deployed in step 4. So these clusters here, so I deployed the A team and the B team cluster. The final step of their Crossplane composition was to hook up Anthos configuration management to those clusters. The application that I deployed was called security tools. So these clusters, A team and B team, are actually connected to the same Git repo that has a manifest. And if I go into the workloads here in my GCP console, and I pick, let's pick the B team and the A team cluster, and I'll pick the Google namespace, I'll see that there's a security tools pod running in each of those clusters. That's what I deployed. So I didn't have to, do like a follow-up Jenkins, kubectl, apply f, or any of that.
Security tools is your application.
That's my app, yeah. This is
Okay.
the deployment spec for the security tools app in the container.
Okay, thank you.
Yep.
All right, Brian.
I'm at time. Thank you
That
all.
was awesome.
Cool.
And that question was great, by the way. You caught the fact that we didn't deploy an application. So
Yeah.
what's the point of building the highway if there are no cars